I really wanted to talk about sort of like what is the role of the data scientist in this new future that we live in? Sort of like where, for those of us who identify as a data scientist, like where do we fit in? Where's our value? And over the last couple of years, I've gotten the opportunity to build a product for data scientists that uses AI heavily. And that was a really great experience, and I learned a lot from that experience about sort of like what data scientists can benefit from in the LLM space, very much related to the last talk. But I also learned another thing on the side, which is sort of like what is unique about the data science perspective that you can bring to building AI products. I felt like I learned some really exciting things. And so today I want to talk about sort of, building AI apps like a data scientist. But before we get started, it's a little early, so I want to brew a cup of coffee for you. Sean, do you need a cup?
Sure, yes.
All right, cool. That sounds great. So for those of you that might know, brewing a great cup of coffee is a series of steps. And so, let's get started. So I'm gonna, pull out my funnel. So there's my funnel. And so we're gonna brew some coffee today. I think the first step is, I need to get some coffee here. I have my funnel, which is great. That's the first step. So I'll pull out some beans and get started. How many of the people in the audience are into like fancy coffee, like third wave coffee? Great. So for those of you that like are into third wave coffee, you kind of may be familiar with this process, this set of steps that I have to go through. And so we'll start with the first step. Pour my coffee in my funnel. All right. Sorry, it's just nerves. Sometimes I screw this up. Let's try this again. All right, go to the next one. I obviously need a filter. It's not just the funnel, it's also a filter. We want to stop bad things from getting through. So we'll do that. And I'm going to reuse these beans. Shit. Okay, all right. So I swear I'm not too bad at this. I've done this before. Okay, I have another one though. That's okay. I always come prepared. It's important to have sort of multiple experiments going at the same time, as our first talk told us about. I think one step that I kind of forgot about is grinding. And so go ahead and start that process. Need to make sure I weigh the beans out. So I brought my scale here. That's good. It's important to weigh out the right number of beans, because if you don't weigh out the right number of beans, then bad things can happen. All right. So for those of you that have never done this before, a grinder is sort of a really essential part of the process. You can go to the store, you can have them grind your coffee for you, you can buy it pre-canned, you can sort of, what's a great analogy for this? You can let somebody else be responsible for the results that you're going to use rather than kind of producing those results yourself. Maybe like a service almost. So anyway, so grinding coffee there's a lot of variables involved. I've done a lot of experimentation. Over the years, I've made thousands of cups of coffee. I've hand ground every single one of them because I don't really like electric grinders. And one of the things that's really important when you do lots and lots and lots of experimentation on a product that you really care about is a concept called drinking your own coffee. I mean, dog fooding. Yeah. So dog fooding your product, you learn a lot about it. And so you learn sort of like what makes it good, what makes it bad. All right. So, Sean, I hope you're ready because your cup of coffee is coming soon. Hand ground. You saw me do it, and so here you go. What temperature do you like your coffee? Oh, that's awkward. Shit. Okay. I really should have predicted that. Some people are really into the cold brew thing, and it's not really my cup of tea. But that's okay. Try this again. So again, it's good to be prepared. It's good to really learn from your mistakes. Do error analysis. We made a couple mistakes here, and we've learned from those mistakes. And so we're going to keep trying. So when you're thinking about building AI applications, you've sort of farmed out a lot of the work to another service, and you've decided on some important products that you really care about. You've maybe talked to one of your users to ask some of their preferences, and you've tried to get to a sense of sort of like what matters. And we've already zeroed in on some of the things that are really important here. And we're getting close, I promise. So I see my kettle is getting close to temperature. One hyperparameter that I set at the beginning of this process was 207. I hope that's an okay hyperparameter for you. I didn't do a whole hyperparameter sweep for this particular presentation, but we can follow up. Yeah. So, do you have any priors for sort of how much coffee you want me to make?
I usually make 12 grams.
12 grams of what?
12 grams of beans. And 16 times 12. I don't know what that is.
Yeah, sure. So, damn. I didn't put this on the scale. You know, this is okay for you, right? This one, wait, is this not good enough? Is that not, okay. Okay, you know what? I think I can nail it this time. All right, you know, we're low, but a 1:16 ratio, that sounds right to me. I like that ratio. That's one of my favorite ratios. And so any mathematicians in the audience can do 12 times 16 for me? All right, we'll do 200 grams. So we're gonna do 200 grams of water. We did about 12 grams of coffee. Perfect. And so this is awesome. We've learned from our mistakes. Each of these little experiments that we've run has taught us a little bit more about where my process fails, where me as a coffee agent is really not serving the user's needs and is really failing to sort of observe the outcomes. One of the things that's interesting is I wish I would have learned how much coffee you wanted in that first experiment. Man, what was my missed opportunity there? Yeah, well, how did I miss that opportunity?
Well, we never talked about it. You just started.
Oh, man. Right. But I feel like we almost like so quickly realized that I was doomed that we never even had a chance, right? One of the things that I failed is immediately I realized that it was not going to work out. There was just like other things I didn't even get a chance to kind of observe. I never had a chance to observe the failures downstream of that first upstream failure. Now, Sean, do you want me to just dump all the water in here?
Yeah, 100%.
Okay, perfect. We're going to skip over that one. But for those of you in the know, I'm also going to use a specific pouring technique that I've learned over years. This is sort of a thing where I like tell the kettle exactly what I want it to do. And through a series of specifications to the kettle, I get it to behave the way I expect. The specifications are sort of like, don't tip all the way, pour very slowly, pour in a couple different pours, let it drip through. This really precise specification of the kettle has taken me a long time to understand how to control the kettle. You can think of this like another hyperparameter, but it's more rich and contextual than a normal hyperparameter. It's not just a number like some of the other things. And so here we are, finally, at 200 grams of coffee. So, the way you bring...
I really hope it's good.
Yeah, no pressure, right? So one of the things about brewing a great cup of coffee is there are multiple steps. And they're all things that, if you're really passionate about this, what's up? Oh, damn it. I fixed this once already. Sorry, everyone. Thanks for letting me know. Long story short, it's not that spicy, so. So there's these steps, and you learn these over time, and you practice, and you practice, and you get your preferences, and you tie human preferences and real data back to the process. And the series of steps is actually quite dependent on one another. As we saw, I never got a chance to screw up the pour until I'd already failed to use my funnel to begin with. And I never even got a chance to think about what the user wanted in terms of a ratio. I never got to get that human feedback until I had actually kind of passed a previous hurdle. There's all these roadblocks in the way. And so these are opportunities for things to go wrong. And these are specific places to look for what caused a bad cup. So we're going to return to that idea several times throughout this talk. And while we do, Sean, enjoy.
Really appreciate it.
So what do great evals do? Evals, for those of you that aren't super familiar, are a way of sort of understanding the performance of your AI applications. You've probably heard this 1,000 times, evals, evals, evals. If you're not building evals, what are you even doing? Start with evals, blah, 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 blah. And I really believe all that. But I think I want to be really explicit, first off, of like, what do great evals actually do for AI applications? And not just AI applications, but especially so. They tell you which of your assumptions are false. That's what actual evals are for. Do you assume that the agent is going to output in the format that you hope? Well, an eval is a way to find out. Do you assume that telling the agent to sort of speak in the way of sort of a Monty Python skit? Well, you're assuming that it knows who Monty Python is. To build a successful capability, you need to overcome a series of steps or assumptions. So did the AI succeed in the job the user hired it to do? This line in red is what we really care about. I'm hiring the AI to do a job for me. And I really want to know with these evals is, can it do it? But unfortunately, this is where I see most people go wrong, is this line right here. Everyone is so obsessed with this, and it's right, but it really misses an important piece. Before we can even assess that, there are a bunch of assumptions that if we don't validate, we have no chance of providing any value. And so now is the time where I have to ask, like, did the agent succeed in the job that the user hired it to do? How was the coffee?
Great.
Awesome. So that's awesome. But I didn't ask him if this coffee was any good. And I didn't ask him about this one. And so like, I didn't even have a chance to really get that feedback from him on these other ones because they failed so early in the process. I want to go back a bit. I want to go back to sort of the origins of evals. One of the core papers in this field is the Codex paper, which introduced pass at K. For those of you that are a little bit more on the data science and statistics side, this paper is probably really easy to read. Some people find it a little bit challenging, but for this audience, I think it's probably relatively tractable because it basically just asks the expected value of whether or not a particular so given a distribution of responses from the agent, what likelihood do they have of, sorry, I'm getting a phone call. What likelihood do they have of like being correct? And pass at K was introduced specifically because the old way of thinking about evaluation for LLMs didn't work. So blue scores didn't work. There's this kind of somewhat famous visualization from the paper where blue scores are not a great predictor of outcomes. They introduced this really essential concept of execution evaluation. If you execute the outcome, does it yield the result you're looking for? And so this is like the very first sort of like genesis of this. But even in that paper, they already started to hint at the sequential nature of evaluations. They already started to call out that as the number of chain components necessary to achieve the goal, the likelihood of success goes down. And so another thing that you've probably thought about a lot as you're rolling out new AI features every week, constantly shipping, is better A or B. And so previously, model evaluation bake-offs are sort of like, is this one better than that one? Well, I need to know, like, which one's better? Maybe there's a new model that came out this hour. Did you benchmark it yet? Is it better? Well, better by what sense? Some of you are accomplished statisticians, and so you can, be very smart, and you can do a two-tailed t-test, and you probably realize that this is absurd. because unfortunately you don't have an infinite distribution of evaluations to pull from. And so this kind of testing is actually pretty ineffectual. It kind of doesn't make any real sense unless you have hundreds of thousands of evaluations to sample from. And so this is actually a really frustrating thing for those of you that really care about the performance of different models and kind of side-by-siding them and understanding how they evolve. This is pretty frustrating. It can be very difficult to give clear answers to the question, is this better? It also applies to things like new prompts and stuff like that. So then you might go down the route of state machines. You may start thinking like, wait a minute, these things are kind of like state machines. They're evolving through time. And this is actually also not new. This is an older paper. And so you can think of sort of like moving from one state to the next state and asking, how does things evolve? Previously, you were in the state of no document content. Now you have a list of retrieved docs. How likely did you get from there to there? How likely did you get from the query results to the correct results summary? These are dependent conditions. There's a causal dependency here. And so you can see the sort of like evolution of this in the literature. You can see it building up. And then even recently, you get this concept of checkpoints. Tasks are divided into checkpoints, representing intermediate milestones. And each checkpoint is a number of points. And so you can see that as recently as this month, this paper was released talking about sort of like how you need checkpoints to understand the evolution of your AI systems and capabilities. And so this is a very long way to say that we're sort of going down this path of sort of like a state machine evaluation where every stage is a piece in your eval system. Unfortunately, a lot of the evals frameworks have a lot to sell, and unfortunately that means that they're not necessarily telling you the truth. And so you can see that they're starting to scratch at the door here a little bit on some of this, but they're trying to oversimplify to sell you things. You see these sort of like trade-off, and now infamous, only a couple days old, but already infamous, this trade-off between agents and workflows. Sort of eval systems are trying really hard to sell you on the sort of workflow end of the spectrum and giving you only tools that work in that paradigm. So, if this feels a little abstract, if this feels a high level, I want you to take a minute, smell the coffee that I brewed, because we're going to do some examples. So at my last job, I worked on natural language to SQL. This is not the only thing that we did, but this was a big part of our endeavor. And so natural language to SQL is sort of like almost like the hello world for like applied LLM stuff, especially for data scientists. It would be really nice if we didn't have to write SQL every time we had an analytics question. And so you can ask the question, how's our ARR this month? And you can determine whether your LLM and the specific RAG system that you built and all the metrics warehouses that it's connected to and all that, you can say, did it tell me the right number? And there you go. There's your binary eval. Ask question, get answer, we're done. But unfortunately, when you're trying to build this stuff in a really like production-y way that really serves a lot of users, it can be more useful to ask a series of questions. Can it generate syntactically valid queries? Luckily for us, we live in the intelligence age, and so most of the LLMs at this point are quite capable of generating syntactically valid queries, with the exception that SQL flavor can have an effect. Snowflake, for example, it loves to generate things that are not allowed in Snowflake. Can it generate queries that execute without errors? You may think this is synonymous to the previous, but that's also not true, because if it tries to select on columns it doesn't have, well, that's a problem. Can it generate relevant results? Does it actually query the databases or tables that are related to the query? Does it generate queries that match the user intent? Does it think about ARR in the same way that you or your business stakeholders think about ARR? And finally, does it solve the problem? Does it add those business caveats? And so you can see here, like, ultimately, the thing we get to at the end is, does it solve the problem? But it can be really impactful to break that down and try to understand all the stages on the way to solving that problem. Because all of these are opportunities to uncover mistakes that it may have made along the way. When I failed to brew Sean a coffee 4 times, it's interesting to say like, man, I suck at brewing coffee. But it's even more interesting to say like, okay, like I brewed this coffee and it turned out really like watery and kind of bad. And the reason was because I didn't put enough water in. And so it's much more interesting to say, like, let's talk about where I made the mistake. Where did I go wrong? And so it's really, really effective to break these things down. And it's really, really important and intentional that these are dependent steps. They sort of censor the rest of the pipeline somewhat intentionally. The more that you can kind of have these ablate the rest, the more that you can sort of understand the causal issues with your pipeline. So the way I think about this is you decompose your capability into as many meaningful steps as possible, each masking the following steps. Here is an example of the Hex team evaluating the new GPT-4.1 model. You can see here that there's two bar charts, if you like, but these are actual funnel charts. And so for those of you that have spent a lot of time doing data analytics, you're probably used to looking at funnel charts. At what stage in the pipeline do things fall off? Do they fall off in the first stage, the second stage, and so on? This is a really effective way to very quickly get a sense of, okay, what's going wrong? Where are things bad? If my CTO asks me, how's the new model? And I say, holy shit, it almost doubled performance. It went from 54 to 93. That's really exciting. We're probably going to launch it. And according to the first talk today, we're just minimizing risk, right? We're trying to minimize the risk of missing out on this opportunity to serve all of our users this really great experience. And that's awesome. We should definitely do that. But I also want to know how. How did it improve it? Where did it improve it? What changed? Well, that's what the other bars are for. You can see that nothing starts changing until the table selection, which is here. You can see that the table selection actually improved as well, quite dramatically. So you can see that there's actually these components that you want to look into. So the new model is not just doing a better job of getting the query right, but it's actually doing a better job of selecting the right table. And so you can probably understand that as I uncensor some of those examples by selecting the right table, I'm going to get more correct data. Maybe those were times where I would have gotten correct data to begin with. In the above, you probably want to understand how did that happen? And so for that, I bring you yet another old visualization technique called a flux chart. And so a flux chart for funnels is sort of where do things go? Where do they start and where do they end up? Do they start at one stage of the funnel and after the change, do they end up in another stage? This is a very simple way to sort of aggregate all that information. And the real magic goes even deeper, because it's not just what has changed. It's specifically the ability to understand which particular evals, which examples. Look at them with your hands. And so for that, I go even deeper and I go even further back into the visualization toolbox. And so for a lot of you probably know this one too. This is a transition matrix. It's a transition matrix with fancy coloring, I will admit. Good is green, bad is red, just for my own simplicity. But you can understand now exactly when I make a change, when I change something about my pipeline, what is the effect? And this allows me to really put my hands on every single example and understand. So the production one that we built of this, you're able to sort of hover over these and see the individual evals and try to understand what's going on here. The power of being able to go all the way down to the individual evals and all the way down to the individual steps, what's changed, is a lot of sort of prescriptiveness about where to go next. So from my perspective, this enables the experimentation to have a lot more impact on sort of operations, which is always one of the tricky parts about being a data scientist. How do you take observation and turn that into operation? So there is this kind of question right now around sort of what is an AI engineer? There's a lot of discussion about this. Are they SWEs? Are they MLEs? And sort of one thing that I learned after hiring a team of AI engineers is that data intuition is a really, really valuable and crucial piece. And so whether you come from a SWE background or an MLE background, I don't have a huge preference, but what I do care about a lot is that you have a lot of data intuition. And of course, there's always an opportunity for a new dumbass title. So, I just want to say thank you. I also want to specifically thank the Hex team who did a lot of this work with me and sort of co-developed these frameworks. That's all I have for you today.